Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to look at the topic functions. Okay, and we are going to concentrate on core math word functions. So this will be lesson 1 of what functions. Okay, and quickly let's go and have a look at what the lesson or learning objectives for this particular topic and maybe this particular lesson. So let's go and look at the objectives. So as a result of studying this topic, the students will be able to, so the first objective, understand the concept associated with function. So this is a general objective. Then we come to the particular objectives here. Define a function and identify functions. Know the notations of functions. Know the basic types of functions. Evaluate functions. Perform basic algebra on functions. And with the algebra, we mean add functions, subtract functions, multiply functions, and divide functions. Okay, then find the value or values of x for which a relation or a function is undefined or not defined. And last but not the least, find the value or values of x for which a relation or a function is 0, what we usually call the zeros of a function. So this will be the learning objective for the entire lessons onwards on functions. However, for today's lesson, we are going to end here. Evaluation of function. That is going to be our target. So it will be from here up to here. Hope I'm clear.
Yes, please.
Okay, wonderful. Okay, so now quickly let's go and look at what a function is. Okay, before we do that, in JHS, you all did relations and mappings, right? You remember you did mappings. I know one of the topics that I used to like, in fact, I like in JHS, especially when you are asked to find a mapping rule, okay, and you are able to manage, maneuver your way around the rule and get the rule. You become so happy when you test and you realize that, your rule, that you are bringing out satisfies whatever you have there. You also did that in JHS, right?
Yes, please.
Okay, very good. All right. Okay, so quickly let's go and look at what a function is. So a function is a relation or a mapping in which each element in the domain, maps, onto, it should be onto, exactly one element in the codomain. So quickly, let me effect the change there. Okay, it should be onto, maps onto exactly. Okay, one element, in, the codomain. Okay, and anytime you mention a relation, every function is a relation. And whenever we are dealing with a relation, you should know that, we are looking at a connection between two, quantities. Okay, so I said, functions are basically relations. Okay, only that they are special relations or special mapping. Okay, having a particular, connection or property. And the property is that every input, should have exactly one output. Meaning every element in the domain, all the elements in the domain are called the inputs. Okay, should, map onto exactly one element in the codomain. So meaning it should have exactly one output. Okay, the codomain will be the set of all possible outputs. Okay, if you remember in JHS, you did all that. So that's why I have here, that is, each object has exactly one image. So immediately you have one object, having more than one image, and it means your relation or your mapping that you have there ceases to be that of a function. It remains only a relation or a mapping, but not a function. So functions are special forms of what? of relations or mappings. So it means every function is a relation or is a mapping. But not all mappings, not all relations are functions. Because for a relation or a mapping to be a function, there should be a particular condition. And the condition is what I have stated here. Each object has exactly one what image. Is my point well made, or I should come again?
Please come again.
Okay, let me see if
Sir,
I can.
please.
I should come again. Okay, let me see if I can use this illustrative example, okay, to come home my point. Let me move on to the next slide. You know, in JHS, whenever you were dealing with mappings, you have something of this sort. Okay, so let's say I have A, B, C. Okay, then usually we call this X. Okay, then this Y. X map onto Y. Ah, okay.
Yes,
Okay,
please.
then we got maybe 1, 2, 3, 4, okay, 5. Okay, so at this point, let me say A will map onto 1. Okay, B will map onto 3. Okay, C will map onto 5. Okay, and D will map onto 2. This is what we have here. Now, okay, you can see that if you look at this, remember I said all the elements here, this will be your input, okay, element or your input value. And here I'm dealing with what letters anyway, and they will be values, they will be regarded as values. This will be your input, okay, and where you have the arrow moving onto, the elements there will be what your outputs. I hope you get my point.
Yes, please.
Okay, and the outputs are what we call, okay, the images, and the inputs are what we call the objects. Is my point well made?
Yes, please.
Okay,
Yes,
very good. So if you look at this carefully, okay, automatically there's a mapping. Obviously, you can see there's a mapping. Okay, and every mapping, like I said, is a relation. Okay, now let's see whether this mapping or relation that we have here is what? Is that of what? Of a function. So let's see, how many images, okay, do we have A having? A is mapping onto how many elements here?
1.
1.
1. So it means the image of A is 1. That's the only image of A. The image of B is what?
1.
No, the image of B.
3.
3. Is it clear now? You can see that the
Yes,
arrow from
please.
B is moving towards 3. Okay, then C. What is the image of C?
5.
5. Very good. That's of D.
2.
2. So you can see that A, B, C, all of them, they have exactly one what image. And once you have all your input there, giving you exactly one output. Okay, is what you have there is what? A function. Is my point well made now with this illustrative example?
Yes, please.
Please.
Okay, now if that is the case, I'm going to give you another mapping and I will ask you whether what you have there is that mapping or that relation that you have there is part of a function or not. Then you give your reason. Any answer that you give, you attach a reason. So let me say, okay, 2, 3, 4, 5, okay, 6. Okay, let me use U, V, W, X, Y. Okay, so I think that will be okay. So 2 maps onto Y. Okay, 3 maps onto you. Okay, 3. Let me clear that. Forgive me. I hope I'm recording. Am I recording? You can determine that from your end as well. Am I?
Yes, please.
Okay. So 3 maps onto, okay, W. Okay, 4 maps onto Y. Okay, and then 5 maps onto, okay, what do you call it? X. Okay, then 6 maps onto Y. Okay, so study the mapping that you have there clearly. So let me call this again X and call this, okay, maybe capital X, also X and capital Y. Okay, all right. Okay, so let's see. Look at what we have there, the mapping that we have on our screens carefully. Is the mapping that you have there, okay, a function. I will ask you one after the other. You give your reason, you give your answer, then you, okay, give me the reason behind your choice for, okay, that answer. Okay. Okay, so Janice, let's go. Is it a function?
No, please.
Why?
This is because some are having more than one images.
Okay, so which will be?
For example, 3
Mm,
is having 2 and W.
it's having,
U and W.
okay, you meant, okay, U and W as its image. Okay, so that is your answer. Okay, so let me see. Serium, your answer and your choice. I mean, your reason for your answer.
It's not a function
Why?
because they said a function maps to exactly one element in the codomain. And for example, 4 is mapping to Y. 2 is also mapping to Y, and 6 is also mapping to Y. So
Not exactly so. Okay, all right. Maybe prove it. Okay, again, I will come and ask you that question. Okay, so, okay, I think as your answer, this is not a function. Okay. However, this is supposed to be the reason. Dennis had the reason perfectly, okay, said. Remember, for every relation mapping to be, okay, a function, okay, you should have, okay, all the get here having exactly one image, exactly one output, mapping onto exactly one element. So your uh, what do you call your condition will depend on the input and the output. But for the inputs, you should have only, okay, any input here, you should have only one arrow moving from it. So if you have an input, okay, if you see 2 arrows moving from that input, then it means it's going to give you more than one image. And you can see that 2 has only one image, which is Y. 3 has 2 images, which will be U and W. 4 has 1 image, which is also Y. 5 has 1 image, which is X. And 6 has 1 image, which is what? Y. So, but for 3, what we have here, the object here 3 or the input here 3, this would have been what? A function. But because 3 is having more than an element that is mapping onto, meaning more than one image, it makes what we have here not a function. So again, okay, I can write here that this is not, okay, a function. So take note per what you said, Serium. Okay, you said that because you can see maybe 6 and 4, all of them mapping onto Y? Okay, no, you cannot. You can see that if it's 4 maps onto Y, 6 maps onto Y, but the image of 4 is still 1, Y. The image of 6 is also 1, which is still Y. So image of 4, 1, image of 6, 1. Okay, so I can even have this, my mapping to be this way. Let me say A, B, C, then Z. Then say A is mapping onto Z, B is mapping onto Z, C is mapping onto Z. All my elements here can map onto Z. Okay, no issues, because this is still a function. Just because the object A is having only one, okay, image. The object B is having one image. The object C is having the same image, one image. Only that the image points are the same. But still, they are all moving on to one image point. Is that clear? They all have exactly one image. Is it clear now?
Yes, please.
Okay, so
Yes.
now you should be able to identify, okay, functions, okay, and non-functions, especially when they come in the mapping word form. Is my point well made?
Yes, please.
Okay, very good. So I will go back a little. Okay, so now that you know how to use this, so let's, oops, okay, I'm supposed to go back. Okay, so this is supposed to be it. Okay, I need to explain this. Okay, in the definition, you can see that, okay, you have domain and codomain mentioned there. So I just want to throw a little more light on that. Okay, and add this one as well. So the domain of a relation or a function is a set of all possibilities of the relation or function. So, okay, you should know. I'll go to what we just did and we'll try and pick, okay, or extract domain, okay, from that or the diagram. The domain basically would be the set. Okay, domain is a set. So you have to make sure when you are bringing out your domain, you put your element, make it a set. Okay, then he said that is, okay, the set of all values that go into the function. So your input will be what you put into the function, what goes into the function. Okay. Then you come to codomain. So codomain of a relation or function is the set of all possible outputs for the relation or function. So all possible outputs, all possible outputs. And you know where you can get your output, okay, point or object or element. Okay, so in this case, I said that is, okay, set of all the values that come out of the function. So outputs coming out. Okay, so all the set of, okay, element that can come out of the function. That would be the domain. However, okay, take notes, okay, of this definition range. This is also the set of all actual outputs. You can see that for the codomain, we said the set of all possible outputs. So possible, there's a possibility that this will be an output. However, when it comes to the range, you are looking at all the actual outputs, okay, of the relation. That is the set of all the values that actually comes, okay, the values that come out of what a function. So if you look at what we did, okay, if you look at this carefully, the first one, let me call this maybe one. The domain, okay, of what we have, the mapping or the relation, in this case, is also a function, will be equal to, domain is a set, so we are going to list our elements. And we said, you can see that this will be the input, okay, elements. Do you agree? Because we said the domain will be the set of all inputs. So it will be A, B, C. It will be the set made up of the elements A, B, C. So that is the domain. If you come to this same one, the codomain, I hope you are following my professors.
Yes, please.
Okay, the codomain, we said, what's the definition of the codomain? The set of all possible outcomes. Is that not it? 4 possible
Yes,
outcomes. You can see that your element here will give us all the elements here are possible outcomes. They are possible outcomes. So it means, okay, your set of possible outcomes will be 1, 2, 3, 4, and 5. However, when it comes to the range, we said the range will be, okay, the actual outcomes. And the actual outcomes will be the elements here that you have, okay, lines mapping onto it, okay, object mapping onto it. So in terms of the range, you can consider one of the elements with 1, okay, 2 has an object mapping onto it. 3 has an object. Okay, what about 4? 4 having an
4
object.
doesn't.
Okay, so 4 will not be part of the range. However, 4 is part of the domain. Okay, is 5 part of, or should 5 be part of the range? Should
Yes,
5
please.
be? Yes, because it is an image point or an output point, as simple as that. So now you know how to distinguish, okay, between, okay, domain and what? Codomain, then codomain and what? And range. So you can always see that the range always be a subset of what the codomain. Whether it's a proper subset or an improper subset, always be a subset of what? Of the codomain. Because they are all, I think you can see. A set here is a subset of this. Can you see that? And sometimes your image, okay, or your codomain can also be the same as what your range. So assuming maybe you had an element here mapping onto the 4, then 4 will now be part of what? The range. Therefore, making the range the same as the codomain. Is my point well made?
Yes,
Yes,
please.
please.
Okay, so if you come to this, okay, relation, this mapping, this is not a function. So in terms of this mapping or relation, okay, the domain is set of 2, 3, 4, 5, 6. The codomain would be W, X, Y. However, okay, the range would be U, W, what X, what Y. Is my point well made?
Yes, please.
Okay, all right. So if that's the case, then now let's go and look at function notations. Before we look at function notations, any questions? Any
No,
questions?
please.
You are fine. So it means you are following.
No, please.
Okay, great. You are doing well. Okay, so far, so very good. We thank God. Okay, so now let's look at function notation. Anytime you encounter functions questions, okay, you see any of these two notations, okay, just because functions are best represented in these what forms. So function or a function may be represented in 2 forms. The first form is the mapping or the arrow form. Okay, and when the function is stated in the mapping or arrow form, this is how it comes. Okay, the name of the function is what you guess. Here, this function is f. And you know when you are doing, when you have two sets, how do okay, how do you read this? I'm writing something. How do you read this? In terms of sets, how do you read what I've written here? Okay,
X is X is
X is,
equals to
X is what?
S is such that
Very good. Okay. So you know that's all that I want to hear. The rest, okay, I'm not interested. You know, this okay, column that is up there. You will read it as what? F column what X. This in math is read as what? As okay, such that is that clear?
Yes, please.
Okay, so this will be read as F is such that X maps to 2x plus 3. And the reading is what I have stated here. So read as F is such that X maps to 2x plus 3. That's how you read it. And the relation form is going to be, okay, and the relation form, this is what you see. You see F in brackets X is equal to 3x plus what? 1. This is just one particular okay, function. Okay, you can change this just as we can change what we have. But please, you don't read this one as f into bracket x is equal to, you read this one as f of x, f of x. So f of x is equal to, so what you have here, okay, is where the problem is. As for this one, you know it's equal to, you also read this one as 3x plus 1. How to read this is my concern now. So this would be f of x. So anytime I mention f of x, you should know exactly what you are supposed to write. Is my point well made?
Yes, please.
Okay, so meaning f is a function of x. F is a function of x. But we simply read that as f of what? X. And let's look at whatever that you have here. I said this will be the name of the function. Okay, and this will be obviously your inputs. Okay, the function depends on x. And the whole of this will give you your outputs. Okay, which, okay, will always be the same as your range. And okay, it will also be indirectly the same as the codomain. You said you read the whole of this as f. Any questions before I move on? So these are
No,
the forms that you usually use the functions being represented. Okay, but take note, the first form, the first, okay, seen in questions. However, in every math question, usually when you are extracting the information, if the function comes in the mapping or the arrow form, when you are extracting it, don't extract it in the mapping or relation, sorry, the mapping or arrow form. Always extract it in the relation form. And every function in the mapping form, you should be able to, okay, write its corresponding relation form and vice versa. Okay, so quickly let's look at, okay, I think before we come to the types, okay, let's see. So in the same way, if I have a mapping, a function in this form, let me call J, okay, and usually use the following letters, F, okay, J, H, small f, small j, okay, small h, represent, okay, functions. But that's not to say that functions are always stated in a small letter, aimed with small letters. You can get functions in capital letters, only that usually use small letters. Is that clear?
yes,
Yes,
please.
Okay,
please.
good. So now if you are with me up to this point, then I'm going to write this. Let's see how we can write, okay, mappings in the arrow form, change it to the relation form and vice versa. So if I have J is such that X maps to, okay, maybe 1 minus 5X. Okay, this function is in which form? It's
The
stated
mapping form.
the mapping
Mapping form.
form. Very good. So this is how you get the relation form. The relation form will be J, then X will be J of X. And this now changes to equal to, then it's 1 minus 5X. So I hope you get my point, which will be J of X is equal to that.
Yes.
So when this is given in question, you extract it in this form. So let me see if indeed you have understood. I'll write one more, then call one of the corresponding relation form. So H is such that X maps to, okay, 6X plus 2. Okay, so let's go. What will be the relation form? How would you write it?
H of x
Very
is
good.
equal to 6x plus 2.
Very good. Okay, well done. Okay, so it means in the same way, if the function comes in this form, you should be able to go back. All correct?
Yes.
Okay, very good. So then I'll move on. So the next thing that you are supposed to know will be the types of functions. However, okay, I am going to be silent on that a little. Okay, and I will ask you to read on it. Okay, prepare a short note on it. Okay, at the right time, I will ask you to. So these are the various types of functions. The ones in red are the ones that usually see in format. Okay, these are the types that you should know in format. And these are the types that I want you to directly write. Okay, short note. Take note of that. Okay, and okay, the first type of the functions is for. These four will be treated, okay, in elective math fully. So you know what a composite function is, because we'll do composite function, what an even and odd functions, okay, or even and odd functions are, then polynomial function, then what rational function. These are all functions that specially, okay, will be treated in elective math. Okay, so I don't want you to write any short note on this, but rather on the first set. Okay, these ones. Okay, one-to-one function, which is what we call the objective function. Any to one function, onto function, objective function, into function, constant function, linear, quadratic, then identity function. These are function types that you should, okay, are aware of. So now let's see how to evaluate functions. The main reason why are here to how to evaluate functions. Remember, in algebraic expression, okay, anytime you are asked to evaluate, okay, any algebraic expression, indirectly you are usually, or you are basically being asked to find a value of the expression, giving certain, okay, values of the variable or variables that you're expressing, or basically simplify expression. But when you use evaluate, then it means you will be doing substitution of some sort, okay, into the original expression. So take note. So it's the same concept that you are going to use. Don't get it twisted. Okay, this one, take note. Functions are basically expressions. They are expressions with a special name. That's all. So just as we can evaluate expressions, we can evaluate functions, because functions are basically expressions, but expressions with a special name. Is my point well made? Or I should come again?
Yes.
Okay, so let's say if I have this expression, 3x squared plus 4x minus 1. This is a quadratic expression. Okay, I can give this expression a name, and I can call this f of x. Or f is such that x maps to. It's still f of x. I've given this expression a name, and it is now a function with the name f. You get the point now?
Yes, please.
Yes.
Okay,
Please.
very good. So now this is how you evaluate, what do you call it, functions. One, substitute or replace the functions variable, which is the input, and the input is what you have here as a variable. Remember, we said this will be the input, and the whole of what you have here be your output, with the indicated number or expression. So it means you can evaluate a function at a number or at an expression. Take notes. Then two, okay, simplify the result. So after you plug in, okay, your new inputs, okay, you don't end there. You substitute, simplify what's the result. Okay, as simple as that. And this is an illustrative example. Okay, if f of x is equal to 5x minus 3, then implication sign is red then, okay, or it's right, this implies, okay, so we are going to read this as this implies f of 3. So you can see that if you compare, our new input is now 3, so it means x is now 3. Wherever you see x, f of x is now 3. So once you know f of x, f of anything, so it means this x here will be 3 and minus 3. So which will give me 5 times 3, which is 15 minus 3. And that will end up as what, 12. Should I come again on my point as well? Is my point well made?
Mr. Hackman,
Yes, please.
Yes, please. I'm here. Hello.
please, I want to know where you got the 3 from.
Okay, so I said, you can see that the 3 that you have here, I just picked any number. I'm evaluating the function at 3. Okay, I just picked any number. It could be f of 1. You can pick any number, only that if you are looking at f of 1, okay, then it means wherever you see x in f of x, but 1, that would be 5, but 1, and which will give us what? 5, yes, is equal to 2. So it means f of 1 is equal to 2, meaning a function f of x evaluated at 1 plus 2. So a 2 will be the image of what? 1. Or 2 will be the output of what? Of 1. You get it?
Yes, please.
Okay, very good. All right. So if that's the case, then we can go and look at more worked example or worked example. But before we come to the worked example, as usual, we've done 1 hour. Okay, we are going for a water break. We'll come back. 3 minutes water break. We'll come back and continue. Okay, so welcome back from the water break. So quickly, let's go and look at, okay, our first worked example. So given that f is such that s maps to 3s minus 2, and j is such that s maps to s squared minus 4s, evaluate the following. So AI, so you have AI up to IV, EI up to IV, and CI up to what? IV. So quickly, let's go and look at how best to present our solution. This is the first time we are, okay, confronted with a question, and okay, we need to present the solution. So please, I need you to be very attentive. Remember, I told you I am too particular about the way you present your work. You have to present it in such a way that it will be appealing to your eyes. And once it's appealing to your eyes, anybody who takes it will equally have that same effect. Okay, so this is it. Anytime you read questions, don't be in a hurry to, okay, lose marks. Make it a point to underline the salient parts, if any. And in maths, okay, these are some of the salient parts that you must underline. Anytime you read any math question and you see true sets, you underline true sets. Okay, find the true set, you underline. Because you know, most often than not, students will not leave their answer. Students, okay, they don't leave their answer in set form. So just conclude with the variable, maybe if it's x, x is equal to, without taking the answer to the truth form. Usually it's painful when you know something and, okay, out of sheer complacency, you lose the mark. If you don't know and you lose the marks, that one is not as painful as when you know and complacency sets in and you don't protect those parts. Okay, so true set, one of them. When you see there is a required approximation, maybe the question said, correct your answer to 2D, correct your answer to 4 significant figures, correct your answer to the nearest whole number. That one too must be underlined. Because if your final answer is not converted to that required approximation, I can assure you, you won't get the final answer score. Then when you see show, you underline. When you see prove, you underline. And again, when you see hence, you underline. So for now, okay, these are the major salient parts that, okay, I want you to take note of. Anytime you read question, underline them just to protect your marks. But here, okay, given that, okay, this evaluate, there are always evaluate function, usually. Okay, so if you like, you can underline evaluate, but it's not necessary. Okay, it's not a salient part. So after realizing that there is no salient part, underline. Okay, the first thing that you write is solution. I have tapped it there just to save, okay, time. So all usually solution will be written. Will be typed. But when you are presenting your solution, you have to write it. And if you want to write a question, you have to write all the questions. It means if I gave you 10 questions, you have to write all the 10 questions before you start. And in exams, usually you don't write questions. So it means in your presentation, what you should write first, after underlining the salient parts, if any, the question will be solution. So I've written solution. After solution, usually questions are numbered. So you should also number your solution. So in this case, there is a major question number 1. So I write solution to which question number? Question number 1. Okay. All right. So Now, this question number 1, okay, that I am going to solve. There, I have information provided there. Okay, the functions that I because to be the function that I will evaluate. If I don't know the functions, how do I evaluate? This information must be extracted. So I'm going to extract the function. However, I said when functions okay appear in the question in mapping or arrow form, which form do you extract? Which form?
Sir, please can I
Relation.
ask the question again?
Okay, remember when we did the forms of representing functions? Okay, I made an emphatic statement that if in the question the functions came in the mapping or the arrow form, when you are extracting it, meaning when you are writing it, how would you write it? Your solution.
Write it in the relation
In the
form.
relation form, very good. So it means here I will extract what I will need. Even that's how I start my after writing the question number, and I will need my function. The function came in the arrow form, unfortunately, but fortunately, I know that I'm supposed to extract in the relation form. So f of x would be equal to 3x minus 2. And if you have space, you continue. I don't have space, and I know that, okay, my g of s will not go there, so I will come down. And anytime you are moving from one line to the next line, always write close to the margin. Come down and write close to the margin where you started writing. So we are going to get what? J of x. Okay, is equal to x squared. Please, I hope you are following minus 4x.
Yes, please.
Okay, so having extracted that, and you can see that this information, the general information about the function, the question number attached to there is 41. So now you come to that question number. So A. Okay, then we are going to do I. AI, what are we supposed to find? F of what? 2. Am I clear?
Yes, please.
Okay, very good. Now, f of 2, what I have here, I've written here, is it an equation? Is it an inequality or is an expression? You pick any of them, then you tell me why. Relation, so is it an equation, an inequality, or an expression? What I've written here. Okay, you need to know that for you to proceed. Okay, because there is something that we are going to write. That's okay. You need to ask yourself, okay, to get the answer to the question that I just asked before you can. It's an equation. My professors, are you there? Is it an equation?
Sir, please, we are here.
Is it that you don't get my question or you don't know the answer?
Please, I don't get the question.
All right, okay, so you let me answer. What you've written here is an expression. Okay, for equations, whatever that you extract, okay, you can see that you extracted this one directly from the question. So if it's an equation, then it will involve the equal to sign. Okay, some sort of. Okay, if it is an inequality, then it will involve the inequality sign, any of them, less than, greater than, less than or equal to, greater than or equal to, any of these four. But you can see that what you have there does not contain equal to or any of the inequality signs. So what you have there is an expression. As simple as that. Is that clear now?
Yes, please.
Okay, so in any time you are giving an expression and you are introducing your steps to expressions, you introduce your steps with equal to. Okay, I think I said this in, you have watched my videos before, is that not it? So I think you are preview to this. I said it in the video that you watched, right?
Yes, please.
Okay, all right. But repetition is just for emphasis. So that if you, okay, don't, now I'm sure that I've told you. Okay, so if you don't do the right thing, I will know. So f of 2, Okay, here, what do you think will be our function of interest? Maybe the function f or the function g. We have two functions here, f and g. Which one will be, okay, the one that we are supposed to be interested in? We evaluate this.
F.
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 So you go to the function f. I hope you get my point.
Yes, please.
Yes.
Okay, and so f of x is equal to this. So f of 2, once you know f of x, you know f of anything. F of 2 means wherever you see x in f of x, so x now is 2, would be equal to 2. So it means this would be equal to 3, x is here into 2. Okay, then minus 2. Okay, which will give us 6 minus 2. So you can see that this is also a step. Okay, that's why I wrote equal to. The next one will also be a step. I'll write equal to. Take note, don't leave spaces in between steps. You only leave a line or two when you are moving from a sub-question to another sub-question. Otherwise, don't leave any line unattended to. So this gives us what 6 minus 2. So you always have to draw your conclusion. Remember, so you come and write, therefore, what will you have to find? What you have there is f of 2. And f of 2, you said you had as simple as that. Any questions at this point?
No, please.
So you are following, indeed, you are following. All right, very soon I
Yes,
will ask
please.
you to do some of them and some. Okay, so now let's move on to the next one. We are going to do I'm moving from a sub question to another sub question. So maybe I leave a line. I can write what am I supposed to evaluate? F of negative 2. So that will be equal to wherever I see x f of x, it's down where there is x here. So anytime you are substitute, please make sure you put it in brackets always. Okay. Whatever that you are substitute for you to play is safe, put it in brackets. So this will give us negative 6. Okay, then minus 2. Okay, and please take note. The next thing that you are going to write, which is the negative 8, okay, that becomes your final answer. At that point, you can come and write therefore, okay, and draw your conclusion. F of negative 2 is equal to, then you write the negative 8. You can see that here there is repetition. Okay, you can be smart and avoid the repetition. Immediately you write, you know that the next step will land at the answer. That next step, draw your conclusion there and write the answer attached to whatever that you have there. I hope my point is well made.
Yes.
Yes,
Okay,
please.
all right. So that will be it for I. Okay, so now let's go and look at I. Okay, so I. What are we giving? J of 3. Okay, so now what will be our function of interest? F of G, the function of interest here is G. Okay, let me quickly add this.
G.
Remember, we said if there's an expression, we start with equal to. Okay, however, if we're dealing with equations inequalities, then you cannot introduce your steps with equal to. Introduce your steps with this. So the implication sign. Okay, so you introduce steps with equal to or implication. By equal to when you are dealing with expressions. Okay, implication sign when you are dealing with either equations or inequalities. So take notes. Is my point well made? So if
Yes,
you are giving
please.
an expression, okay, you are working with an expression and you come and write, this implies 0 is 0. Okay, it doesn't imply, it is rather equal to. These two, we cannot use them interchangeably. If you use implication on this line, it means on the line, there should be equal to or inequality sign there. But on this line, there is no equal to equal. So write what equal to. Okay. Take note of that. So this is an expression. Okay, so I write this implies that, am I right? Am I? Am I? Can I use the implication sign here?
No.
Why?
For just the G of 3.
Why?
Us. It's an expression.
Perfect. As simple as that. You don't start expressions with implication sign. Take note. Okay, so this should be. So if you're able to correct me, you have no business not to correct yourself. Okay, so this should rather be equal to. Take note of that. All right. So at this point, we are good to go. That's an expression. So it means here, I know g of x. So I should know g of anything. So it means now our inputs here, x is 3. So wherever you see x here, it will be 3. So I'm going to get, I have 2 terms in x. So the first one, I substitute my x. I've told you anytime you are substituting, you put it in brackets. The x that you substituted here, okay, there is a square with it, so I square. Then minus 3, sorry, minus 4, forgive me. Let me clear that. Okay, and you should equally avoid deepening. If possible, cancel and write it again. Don't deepen it. Am I clear? So to be 4, okay, times x, and your x now is 3. So 3 in brackets. So that would be equal to 3 squared, which is 9, minus 4 times 3, which is 12. Okay, so if you combine this, we are going to get minus 3. 9 minus 12 will give us minus 3. But I'm matured enough not to write minus 3 and come and conclude with it. So I'll write therefore j of 3, okay, will be equal to minus 3. And please avoid underlining your final answers. Is my point well made?
Yes.
Okay, great. All right. So at this point, I want you to do that of what Ivy for me. Okay. And I will call you to give me exactly what you wrote. Okay, so this will be the g of minus 5. Wherever you see x in g of x is minus 5. So it will give you minus 5. But remember, anytime you are substituting, the advice is put it in brackets. So you are substituting for minus 5. So put minus 5 in brackets for x, then x squared. Okay, then you get, okay, again, minus 5 in brackets. Okay, you remove the bracket. Minus 5 squared, or the whole of that all squared means minus 5 times minus 5, which will give you 25. Otherwise, you feed your calculator with this, give you the same thing. Minus 4 times minus 5 will give us plus 20. And you draw your combine this. You know that at that step of combination, you get your final answer 45. Draw your conclusion. So the next one, this is what we have. BI, f of half. The values are not pretty, but you can still work with them. So f of half means wherever I see x in f of x, it is now half. So this x here is half. So it will be 3 times half and minus 2. And this, you know, check if you can reduce before multiply. We can reduce. So you multiply. Numerators will multiply. Numerators and denominators. It is the same as 3 over 1. 3 times 1, which is 3, then it's over 1. So 1 times 2, which is 2. The 3 will not multiply both the numerator and the denominator. The 3 is a numerator, it can only multiply the numerator. Take notes. Okay, then minus the 2. And I said at this point, you could have used your calculator to move from here to here straight away. Otherwise, if you want to do it manually, you take the LCM, and this will give you what you have here. Every step on the way, don't forget to introduce your equal to's. Distinguish one step from each other or the steps from each other. Then you draw your conclusion. Same for this. For this one, you can cancel. So you cancel. You get 1 into minus 1. But that will give you minus 1. Then minus 2. Then you sum this to give you this. Draw your conclusion. Okay, so now I think, okay, you should be done. Who want to do the J? I mean, the I. Mm-hmm. J of 1 on 4. Who wants to help?
I. J of 1 over 4 is equal to 1 over 4 into bracket squared.
Very good. Failure to bring the square can be costly. So that's why I said anytime you are substituting, strictly put whatever that you are substituting. Hey, let's go.
Minus 4 into bracket 1 over 4.
1 over 4. Very good. The basic advice we're taking.
Equal to 1 over 16.
Very good. It's the same as 1 squared. Okay, over 4 squared, so 1 over 16. Then minus, this will cancel, so minus 1. So that gives you can use your calculator for issues.
Negative 15 over 16.
Okay, so this gives you negative 15 over 16. Is that not it?
Yes.
And you could have drawn your conclusion. You could have drawn your conclusion there because that's your final answer. And the fraction is a proper one. So you could have drawn your, however, you've written it, so you are now going to draw your conclusion. So you always think before you write. By so doing, you write less and save time. So that will give us minus 50. All correct. Okay, so we are fine. Okay, so take note. The IV, okay, you should be able to do it as well. A fraction is an improper, sorry, mixed numbers. So, okay, it's an improper chain to mixed numbers. Before you deal with it, I won't even talk much. Okay, so just use whatever that maybe we've said so far. Okay, together with your sharpness, your intelligence to deal with this. So now C. Okay, C, we can see that, okay, we are dealing with this time around, we are, okay, going to substitute expressions rather than values. Okay, so CI, what are we dealing with? F of minus X. So this is an expression, it's not a value, a variable. Remember we said you can evaluate it at an expression or at a value. Okay, the A and B were values, evaluating, okay, functions at values. But now we are going to learn how to evaluate functions at expressions. So now this is equal to wherever you see X in F of X, it is minus X. So this X here will now be minus X. So this X will be minus X. So I'm going to substitute. So it will give me 3, okay, into, remember, anytime you are substituting, your X is now being represented by minus X. There is not no power, then minus what? 2. So this will give us minus 3X, okay, then minus 2. You draw your conclusion, which you could have drawn here as well. Therefore, F of minus X will be equal to minus 3X minus 2. All correct?
Yes.
Okay, very good. My professors, are you with me? It seems it's only one voice that I'm hearing. Okay.
Please, we are here.
Selim, are you there?
Yes.
Okay, all right. Okay, so now that will be it for what we have here. Okay, so quickly, let's go and do the second one. Okay, so maybe I will see, okay, if you can do the third one, or I'll do the third one and leave the IV for you. Okay, so because of time. So I. Okay, what are we finding? F of what? X plus 1. So this will be equal to wherever you see X in F of X, it is now X plus 1. So it should be 3 times X. Your new X is X plus 1. You put it back, then minus 2. I hope you are following.
Yes, please.
Okay, so now what do we do? You know how to simplify this. Remember algebraic expression. So 3X, okay, then plus 3, then minus 2, which will give us, okay, 3X, then plus 1. So that will be my final step. I can draw my conclusion there. Therefore, my F of what? X, okay, plus 1 will be equal to 3X. These two are like them. So a 3 minus 2 will give you plus 1. You are done. Afa, all correct?
Yes, please.
Great. Okay. So now, if that's the case, let's go and look at what the last question that we are going to do together. I. Okay, so G of what? X plus, sorry, minus 1. Okay, so this will be equal to wherever you see x in G of x. So now our function of interest is G of x, which we have extracted. So G of x we know is x squared minus 4x. So the first term contains x. So I substitute my x, which is now x minus 1. That's not all. It has to be squared. Then minus 4 times my x. My new x is what? X minus 1. Should I come again or you are fine?
I'm
Say,
fine.
please come again.
Okay, all right. Okay, so as for this one, you understood the f of x plus 1.
Yes, please.
Okay, so please don't wait for me to ask, should I come? Remember, I've told you the rule. At the point that you don't get it, let me know. Okay, though maybe frequently I'll be asking, should I come again? But don't wait for me to ask before. So, yeah, okay. In this question, what will be a function of interest?
G.
G. So you go to G. Remember, we have extracted G already. So we know that G of x is equal to x squared minus 4x, which we have extracted. So this means, okay, you are finding G of x minus 1. So it means wherever you see x in G of x, it is now x minus 1. So wherever I see x here, it is x minus 1. So this x changes to x minus 1. So I'm substituting for this x, so I put it in brackets. That's my new x put in brackets. The s there is squared, so I bring the square there. You get it? Then minus 4 into the x. Your new x is x minus 1. So our first is here. It's okay, right? You are fine now.
Yes, please.
Okay, so this is where okay, ordinarily, okay, you should know how to expand a binomial square. Take note of this. Anytime, I think, you watch the video, so I don't have to talk much. I've forgotten our your foundation, and you did quite well. So remember what we did, the binomial square. We said if you have a plus b all squared, that will expand into who will help? The identity. We are applying what you learned over the weekend. A squared plus 2ab plus b squared. Do you remember?
Yes, please.
Then a minus b squared will give us
A square
mm-hmm,
minus
Minus
2ab
mm-hmm,
plus b square.
perfect. So we know this, we are good to go. So at this point, if I'm expanding this, I know my a is x and my b is what? 1. So I'm looking at a minus b all squared. So I'm going to get x squared minus twice the product of this and this. The product of 1 and x will give you x. Okay, twice that will give you 2x. Afa.
Yes,
Then
please.
plus 1 squared you know is 1. Then you come and expand this one too. So minus 4x. Okay, then plus 4. All correct. However, if you cannot expand this using the identity, though I said you should know. Okay, take this one. Don't come and do your expansion the usual way of expanding this. Okay, here. Just take out your x minus 1. Okay, squared. Okay, and go and expand. So you know that this is the same as x minus 1 multiplying x minus 1. So it will not be x minus 1 multiplying x plus 1. Remember, any number squared means the number is multiplying itself twice. So if I expand, I'll get x squared, okay, minus x, then minus x, and plus 1, which will give me x squared minus 2x plus 1. Then you import the whole of this and come and write it and expand this. This happens to be your rough work. You strike it out. But as you mature, okay, before the person will even come and do this and end up with this, you are even done with your answer. Okay, everything all together. So the next step equal to, okay, we are going to combine like terms after expansion. You always check if there are like terms to combine. And here, only one term in s squared. So I write that s squared. Okay, I could have drawn my conclusion there. And indeed, I am going to draw my conclusion there. At that point where I'm combining like terms, that will land me at my final answer. So I can draw my conclusion at that point. I'm going to do that. Okay. Equally leading to my own advice. Okay, so therefore, ij of, okay, x minus 1 will be equal to, what do we get? We are going to get s squared. There is only one term in s squared, followed by the s term. So s term, I have two of them, minus 2s minus 4s. What would that give us?
Negative 6.
Negative 6s, very good. Okay, then the constant, yes, 1, then plus 4. Plus 1 plus 4 will give us,
5 plus 5.
okay, plus 5. So we are done. Okay, with that one. Okay, so that will be it for the solution to question 1. Any questions at this point?
No, please.
You are fine.
No, please.
Great, you are doing well. Okay, keep it up. Okay, I've told you, you need to have this at the back of your mind. You don't write this. If you have to write it, maybe as a guide, it's required. Okay, it's necessary. So this then becomes your assignment. So you've, okay, attained our target. Okay, this will be our assignment. And I want it to be a class assignment. We have about 15 minutes. Okay, so use the 15 minutes to do this and submit. Is that clear?
Yes.
Okay, so
Okay,
thank
sir.
you very much for a wonderful, making the class a success and a wonderful one based on your contribution. God bless us all.